This is going to be assignment 2, case 2, for a plate tilted at 30 degrees towards incoming flow. Here is my ID. It is hard to see with the current camera. My PID is 4065587. Let's begin with the geometry. First and foremost, we need to sketch our plate. So let's zoom in here for a second. Here's our plate. In order to make this plate, you go to sketching. You go to line, you draw a line along the x-axis, and you connect that line to a random angle you can choose. To specify the exact angle, you can go down to dimensions, you can go to angle, and you can actually click this line that you drew and the one on the x-axis and control the angle between them, which I did set to 30 degrees prior to the camera. Next, you complete the square by just drawing the little lines going outwards and completing the shape. In order to get the dimensions of that shape, you just go to general, and again, you draw off these lines from here, and you can specify the height to be 5 centimeters and the length to be 50 centimeters. After that is complete, we need to set our system up, which is the large rectangle you see behind, which is where the flow will be going through. In order to do that, you just draw a rectangle, and that's all you need to do. In order to create the surfaces, you go to Concept, Surfaces from Sketches, you highlight this entire area, and you click Generate, and then you have a surface from your initial sketch on the XY plane. That concludes the geometry portion. Next, I'm going to be displaying the meshing. So this is the mesh I currently have come up with. Let me go to this button. All right, so in order to mesh properly, I first went to here, I clicked Insert and Method, and that inserted the automatic method, which gave me a general mesh over my entire figure. I made the mesh better by decreasing the element size to 0.05 and clicking Generate. And to get the best possible refinement, I went to level 2. This could be level 3 and have even more refined, but because my computer is limited, I just did level 2. Click Generate, and this is the mesh we ended up with. For the name selections, this is important. Our inlet for our system is here. This is where flow is going to be coming through. Our outlet is going to be to the right, where flow is leaving. Symmetry is top and bottom of this plate, where flow isn't going to be leaving or entering. It's just going to be stagnant. The front plate is, where is this at here? The front plate is right here. The back of the plate is here, the bottom of the plate is there, and the top of the plate is there. It is important that we recognize those positions and name them because that's where we're going to tabulate our forces in the next step. So in the next step, I'm actually going to open that now. We're going to go over to Fluent, which is this right here. Again, the solution has already been calculated, but it would take too long to do on camera, so I had to do it off camera. I'm still going to show how I get to everything though. So here, the model we're going to be using is K epsilon. We're going to check off enhanced wall treatment and pressure gradient effects. Our materials, all we're going to be using is air. So air, everything can stay constant. For our boundary conditions, our inlet is going to be our velocity inlet, and I set our velocity inlet to 10 meters per second. Everything else can be stay the same. For our reference values, we are going to be computing from our inlet. This should be 10 meters per second. Next, we have our initialization. We will do hybrid initialization, initialize it, and it should iterate in nine times. We can then go to run calculation and calculate. And again, this has already been calculated, so I have all my forces calculated already. I did 250 iterations. I believe this converged in about 40 iterations, so it wasn't that much. Once the calculation has been complete, you can actually go to reports. You can go to forces, print the forces, and then you will have a tab of all your forces acting on your plate right here. This whole area down here. So this is our form drag or pressure drag, or no, not drag, pressure forces. This is our skin friction forces. And this is the net force between the pressure force and the viscous force. And this is the total for the entire body down here, which is quite significant. That will be shown more as well in the report. Next, I'm going to be sharing my screen here. I'm going to be opening results. Give that one moment to set up. And in our results, let me just share that with you really quick and make sure this is sharing. Okay, perfect. All right, we're going to move to our XY plane. We're going to go to Insert, and first we will do our velocity contours. We'll just do this velocity. We're going to go to Symmetry 2. Go to Velocity, and go to 200 contours. And we'll apply that. And here we go. This is a perfect contour of the velocity. As you can see, we have this large wake region in the back and this, this large wake region that extends much farther than the system. But again, I chose a large system in the back so we could see this elongation back here. Next, I'm going to show the pressure contour. I'm going to check off our velocity contour so we can see this pressure contour. I'm going to be calculating Symmetry 2, pressure, and we're going to set this to 200 contours. Perfect, and this looks about correct because when we zoom in here, we can see at our stagnation point, we're going to have the highest pressures. And behind here, we have a section of low pressure, which is characterized by the wake region. I can now look at where the velocity or the flow will begin to separate. So we'll just call this flow separation. And we're going to go to Symmetry 2. Let me take off this pressure contour. We can go to velocity. That's it, actually. We can apply that. And when we zoom in down here, we can see that flow begins to separate at, in the other case, it was about 35 centimeters. It started to separate, but here it's about 28, 29 centimeters that it begins to separate, which is, if we zoom in right here, it's where the end of this, this bluish green vector, right there is where the flow starts to separate. And again, that's because we have this adverse pressure gradient where we have low pressure and high pressure up here. All right, and that will conclude case 2 for assignment 2. Thank you for watching.